Okay, so today we're finishing out chapter 4 with radical equations and power functions. We're not actually going to talk about very much in this chapter. I kind of just wanted to cover the parts that are like, I guess, more generally useful, I suppose. A lot of the other things in this are like story problems and things that you should already be able to put together anyway. So this is kind of just messing around with exponent rules, which I think is interesting and will also be kind of helpful if you go into pretty much any non-algebraic math class in college. So it's probably worth talking about. So first of all, properties of rational exponents. All of you are familiar with the following powers. So you should be able to tell me what 3 to the negative 2 is equal to. You should be able to evaluate all of these probably. I mean, you probably can't do 7 to the ninth by hand because it's going to be a massive number, but you know what to do at least, right? Multiply 7 by itself 9 times. 3 to the negative 2, that's 1 over 3 squared. Square root of 9, obviously. Cube root of 64, fifth root of 32. You all should know all of those things and how to solve them. So today we're going to learn about the following powers. You might already also know some of these, but just in case you don't, that's what we're here to do. So 3 to the 1/2, 6 to the 3/4, 5 to the 5/3. Those could be negative powers, whatever. Doesn't really matter. Before we get to that, though, I want to review some exponent basics, multiplication and division law. These are really important things, and we're going to use some of them. You're going to use a bit in your homework, too. The homework assignment for today is going to be relatively short, especially so that those of you that are in person today when you're watching this won't be missing out on a whole lot. So first of all, multiplication rule. A to the b times a to the c equals a to the b plus c. Basically, if you have the same base and you're multiplying powers, you just add the two exponents together. That one's pretty simple. A to the b divided by a to the c equals a to the b minus c. If you have the same base, you're multiplying things, or you're dividing two things of different powers that have the same base, you just subtract the powers. So for instance, we have 3 cubed times 3 to the 7th. This is equal to 3 to the 3 plus 7, which is equal to 3 to the 10th. And again, you should be able to solve it from there if you were needed to. I would plug it into a calculator because doing that is not fun. 4 to the 5th divided by 4 to the 2. That is 4 to the 5 minus 2, which is equal to 4 to the 3rd. That one's actually easy. That's 64. So cool. Hopefully those ones make sense. Also, really quick, I'm just going to throw this in here. You probably won't use it at all, but if you have like a number like this raised to another power, right? So you have a power raised to another power. This is equal to 3 to the 3 times 2, or 3 to the 6th. If you had like 5 or 4 to the 5th cubed, this would be equal to 4 to the 15th. Because you multiply these in this case. Okay, now we want to look at fractional powers and negative powers. So fractional powers are effectively just radicals. The power of 1/2 is the same as a square root function. So 1 over 2 is the same as a square root. 1 over 3 is the same as a cube root. Let's look at the example of 16 to the 3/4. Now, when we get into things like this, what you want to keep in mind, there are a couple of different like theorems for this, but you don't necessarily need to know them to be able to solve these. You can think of this as 16 to the 3 times 1 over 4. So basically you have the 4th root of 16 and the cube of that. So this is effectively 16 4th root cubed. It doesn't necessarily matter which order you solve these in. I'm going to let you know now that generally speaking, it's easiest to do it with the roots first, right? So in this case, you would take the 4th root of 16, which happens to be 2, and then you would cube that, which would give you 8. So it doesn't actually matter which way you do it in. And I can also go through really quick the other parts of the theorem. So the other things you could do with this, if for some reason you wanted to, is you could say that this is equal to 16 to the 3/4 is also equal to 16 to the 3rd all to the 1/4, if that was for some reason useful to you. It's also equal to 16 to the 1/4 cubed. That's more useful because it's a lot easier to solve. It's also equal to what I told you, the way I would generally write it personally, 16 cubed. You can actually put the cube outside or inside, it doesn't make a difference. And then it's also equal to 4th root 16 cubed, or 4th root 16 all cubed. Now, the reason I didn't really bother to write these all out in PowerPoint is to be honest, most of those are not particularly useful. As long as you know how to solve it, it doesn't really matter. So let's look at simplifying some expressions. Now, I wrote these up by hand because doing these in PowerPoint in the formula maker takes absolutely forever, but I will use a different color to go through the solution to them. So color, let's make it just black. Let me be simple. So for this first one, a lot of students are going to be really tempted to cancel the 4s. If you do that, you're automatically going to get this problem wrong because it won't work that way. So please don't do that. The first thing we need to do is, this is the same as 4 to the 1/3 divided by 4 to the 5/6, which, as we recall from our previous theorems, is equal to 4 to the 1/3 minus 5/6, which is equal to, this is 2/6. 2/6 minus 5/6 is 3/6. 4 to the negative 3/6, which is 4 to the negative 1/2, which means that the way that negative powers work, I guess I didn't cover that and I probably should have. Hopefully you all remember, is this is equal to 1 over 4 to the 1/2, and then 4 to the 1/2 is equal to square root of 4. Square root of 4 is 2, so this is equal to 1/2. Let's double check, make sure we got that correct. We did. Okay, cool. So the next one's a little bit easier. We've got 27 to the negative 2/3 times 27 to the 1/3. So that is equal to 27 to the negative 2/3 plus 1/3. Negative 2/3 plus 1/3 is, of course, negative 1/3. So now we have 27 to the negative 1/3. This is equal to 1 over 27 to the 1/3. And that is equal to 1 over the cube root of 27, which in this case is 1/3. So this one is 1/3. The last one is honestly one of the easiest ones. First of all, I'm just going to get rid of the negative to make this a little bit simpler. So we're going to have 1 over negative 125 to the 4/3. Then we're going to take the cube root of, well, actually, I guess technically this time around, if you try to take the cube root of this, you're going to get, actually, no, it'll work. Never mind. I was going to say you have a negative number that you're taking the root of, but that's fine in this case. You won't get an imaginary number. So we take the cube root of this, we get negative 5. So we'd have 1 over negative 5 to the 4th. That, of course, is going to be a positive number. And basically, it's going to be 5 times 5 times 5 times 5, so 25 squared, which is equal to 625. That's probably not something you would know off the top of your head. You'd want to plug that into a calculator, but this part, the negative 5 to the 4th part. You could also do it by hand, right? 5 times 5 is 25, times 5 is 125, times 5 is 5, carry the 2, 2, carry the 1, 5 times 5 is 6, so 625. So this one equals 1 over 625. Sorry, I'm kind of leaning. I'm trying to get to the edge of my drawing pad to write this. So the next one is about writing radicals with rational exponents. So basically this one we're just working in reverse, right? This is just the square root of x, so we know that this is x to the 1/2. That one's pretty simple. This one we've got x squared, which means the numerator of our fractional power is going to be 2, and it's a cube root, so we're going to have x to the 2 over 3. Again, you're just taking whatever this is, whatever that is. And then for C, there are kind of two different ways you could write this. You've got it being raised to the -5th. You're taking the 4th root of it, which means you have z to the -5 over 4. You could also write this as 1 over z to the 5/4. Either of these works for this one. The book would probably want you to make it positive. I personally don't really care. You can leave the negative exponent in there if you want to. Let me see actually if the book wants it written as, yeah, the book does want it written positive, but it doesn't really make a difference. Now, this one is a little bit trickier. We've got the cube root of y, the cube root, or the 4th root of y, all square rooted. So what this effectively is, we're going to rewrite the whole thing. Y to the 1/3, oops, y to the 1/3, that's this one, times y to the 1/4, that's this one, all to the 1/2. Now let's do the stuff in parentheses first. Y to the 1/3 times y to the 1/4 is equal to y to the 1 over 3rd plus 1 over 4, which of course is not fun. We have to add fractions. Least common denominator is 12. That's 3/12 plus 4/12. So this is equal to y to the 7 over 12, which we're taking to the 1/2. So we just multiply these out. Y to the 7 over 12 times 1 over 2. We get y to the 7 over 24. Let me double check and make sure. That is, so it is y to the 7/24. So that stuff isn't too terrible. Obviously, this last one was a little bit of kind of a gross problem, but as long as you know how to get to this step from here, it's not too terribly difficult to solve. All right. Let's look at the last couple of things. So evaluating radical functions. What this is basically asking us to do is solve this when x equals 27. So in this case, we'd want to take the cube root of x, the cube root of 27. Cube root of 27 is, of course, 3. So now we have 2 times 3 equals 6, x equals 6. So basically, remember we've got this, 2 times 3. Cube root of 27, let me erase that. It's not very helpful. So this is cube root of 27. We solve for that, then we just multiply it by 2. That one's not too terribly difficult. The next one, though, we have the 4th root of 2x when x equals 8. So all we do, we plug in 8. That gives us the 4th root of 2 times 8, which is equal to the 4th root, I hate drawing these things, 16. The 4th root of 16, for those of you that don't know, is 2. So x equals 2. Okay. The last couple of things that we're talking about are how to solve equations with square roots in them. Now, hopefully looking at this, every one of you could tell me what your first step is going to be. But you need to get rid of this square root. This is terrible. We don't want this, so we need to square both sides. So that gives us x squared equals 15 minus 2x. And what do you know? You know you have quadratic. So add 2x, subtract 15. And then you just solve it from here. In this case, you have this factor is 2x plus 5 times x minus 3. X squared plus 5x minus 3x, that's plus 2x times 5 times 3, yeah. So x equals -5, 3. Right, so that one's not very hard. You just square to get rid of the square root. And this one isn't too much more difficult either. The key for this one is to make sure that you remember that you need to get this 2 all the way over here first. That way you don't have to do really gross things where you cube this whole side. You can't cube just a single number on a side, or even the numbers individually. You have to cube the whole side all at once. So we want to make sure that things are isolated. So first we're going to add 2 to both sides. We have the cube root of 2x plus 5 equals 3. And then we're going to cube both sides. So that'll get rid of this. And we have 2x plus 5 equals 27. Subtract 5. 2x equals 22. And of course, everybody here Should easily be able to tell that x is equal to 11. So solving things with cube roots and square roots isn't too difficult. It's just make sure that you isolate this cube root by itself. If we tried to cube it at the beginning, we would have to cube this weird function, 2x plus 5 minus 2. So it'd be this times itself 3 times, and that's just disgusting. You don't want to mess with that. So make sure you isolate these by themselves before you actually solve this. Okay, so that's it for this video. Like I said, it's a relatively short lesson. We're not covering most of the things in this chapter just because honestly, we've already been overloaded with stuff anyway. And I thought most of it was kind of extraneous compared to what we've been doing. So hopefully this makes some sense. I don't want everybody getting super overloaded before the test on Thursday. Please make sure you're ready for that. Hopefully you guys will be coming in either today or tomorrow. And I will see you guys all then.